This is a trig formula, and so arc length, we often do it in terms of radians, but without you knowing radians, you can still figure this out. And the formula is, you take the degree of movement, the interior movement here. So for instance, if you go once around, so 60 minutes, 1 hour, this movement of the minute hand would be a complete circle or complete revolution, which would be 360 degrees. So to figure this out, here's the formula we're going to use. It specifically says the length or the radius of the minute hand is 5. And now we need to figure out how many degrees, knowing that a circle is 360, how many degrees do we move from 210 until 530? That's going to go on top. I'll divide it by 360 times this and then figure out which one is it closest to the nearest 10. Well, I know from 210 to 310 is 1 revolution, 310 to 410, 410 to 510. So I've done 3 complete hours plus an additional 20 minutes. Now 1 revolution is 360 degrees, 360. So if 360 plus 360 plus 360, if I add up 360 times 3, I end up with 1080. Now I need to figure out what is 20 minutes in terms of the degrees. Well, I know that on a clock, 20 minutes is 1 portion of the entire thing, which is 60. So 20 minutes over 60 tells me that 20 minutes on a clock, going from this point to this point, covers 33% of the entire circle. Remember, our circle is 360 degrees. That means 20 minutes covers 120. So from here to here is 120. So I take 120 plus the 1080, and I end up with 1200. So I'm going to take 1200 divided by 360 times 2 pi times 5. 1260 divided by 360 times 2 times 5 times 5, and it says to the nearest centimeter. To the nearest centimeter would be 105, option D.